Thank you so much for joining us today for our session, Memory for LLM Applications, Different Retrieval Techniques for Getting the Most Relevant Context. I'm Emily Kersey, and I'm a member of the team here at Zillis. I'll cover a few housekeeping items, and then we'll get right into the session. First, this webinar is being recorded, so if you have to drop off at any point, you will get access to the on-demand version within a couple of days. If you have any questions, feel free to paste them into the Q&A tool at the bottom of the screen. That just helps keep things organized for our speakers and make it easier to moderate your questions. In a few minutes, I will drop in some resources into the chat panel. I encourage you to check out our upcoming events. We've got a great session coming up next Thursday. We've got free resources, and of course, you're always welcome to join our community Slack. Today, I'm pleased to introduce the session, Memory for LLM Applications, Different Retrieval Techniques for Getting the Most Relevant Context, and our guest speaker, Harrison Chase. Harrison is the co-founder and CEO of LangChain, a company formed around the open source Python TypeScript packages that aim to make it easy to develop language model applications. Prior to starting LangChain, he led the ML team at Robust Intelligence, an ML ops company focused on testing and validating machine learning models, and led the entity linking team at Kensho, a fintech startup. And he studied stats and CS at Harvard. In addition to Harrison, we are also joined by my colleague, Philip, a software engineer here at Zillis. Thank you so much for joining us, and welcome, Harrison and Philip.
Thanks for having me. Excited to be here. So I guess we'll just jump right into it now, Philip. And so, yeah, excited to be here, excited to chat, excited to have you with me. I think it should be interesting dual perspectives, right? So like, I think you have you and Zillas and with Milvis and then Zillas Cloud have worked with a lot of people on the problem of retrieval. I'm assuming from the perspective more of like a database. And a lot of my exposure has been from the application building. And I think retrieval is super important. So really just intending to have a fun conversation. We've got some slides. We'll have some back and forth as well. There's the Q&A thing as well. So if you have any questions that you want answered, just drop them in there. And we should just have a fun 50 minutes or however long it is. So today we'll be talking about retrieval in general. Basic overview of what is retrieval and why is it important. Semantic search is maybe the most commonly used type of retrieval, but there are some edge cases, and so we'll cover the basics, and we'll also cover some edge cases. We'll cover some solutions or workarounds those edge cases, and then I want to talk a bit about generative agents at the end, which is just a really cool, more recent paper that came out that combines a lot of these more advanced ideas. So at a high level, and this is a very bare slide. So Philip, if you want to add anything here, I'm sure that this might be a good slide to add some color about like what is retrieval and why is it important? And so the idea of retrieval is bringing external knowledge to a language model. So language models only really know what they're trained on. I think ChatGPT has a cutoff date sometime in 2021. They're also not trained on everything. They're not trained on your corpus of data. They're not trained on sometimes smaller or less common corpuses of data. And then I guess another like reason for retrieval is just to like, I think some people also use the term like grounded generation, just to like really ground the generation in the actual documents. So even if the information is in the language model, maybe it's in there in such a small weight, it doesn't really recognize it. And so you bring it front and center and put it forward for retrieval. Do you have anything else to add here? I'm assuming most people have some concept of retrieval, but I'm curious from your perspective, what you use to motivate retrieval.
I think for me, like a big one is also just kind of giving evidence to the answer. So the thing with these large language models is they can sometimes say whatever they want. And then with these retrieval agents, you can kind of go and see, okay, where was that evidence pulled out? You can kind of list your factual proof, sort of like a search engine style. So you're pretty much using it as a search engine to kind of give proof to what your LLM is saying. I think that combined with the external knowledge, like giving it some info so it knows what it's talking about, are the two most important, in my opinion.
How have you seen like I think the point about like giving like citing sources basically is really important. Like what have you seen people doing there? I think the obvious one is you like ask it to cite its sources and then it like responds with like a list of URLs or a list of whatever happens to be the sources for the documents that you're passing in. What have you seen? Like, do a lot of people like display those? Do they do more like error or internal checking for like consistency with those sources? Like, how do you see those often used?
So we've kind of seen it mainly used as kind of giving your top tier results and giving sort of like a snippet of the text and then kind of giving a link to the actual document. There hasn't been too much analysis to kind of see, okay, on every answer, is this correct? It's more along the lines of kind of giving it a backup and then showing like where it's pulling from. Most of the time at the moment, I know with the retrieval app from OpenAI, over there we were kind of doing that style of kind of listing out where if it doesn't know, I forgot exactly what the exact method it was using to see if it doesn't know. I think internally they might have had some kind of trigger to say, okay, it's maybe time to search over in the vector index. But it was mainly kind of showing the results and showing, because also when you're pulling out from the retrieval, it sometimes also tries to summarize, or a lot of the use cases people use are to summarize it. And this summarization can also go wrong because it could then start pulling things into the summarization. And that's where kind of whenever you are using the vector index, it's worth kind of also giving the search results just in case. So you're pretty sure what's going on and if you need to kind of go back to something. But internally and like kind of large scale usage, it's usually up to the user to kind of look over that factual evidence to see if things line up. But I think there is work going on into that to kind of compare the two. I know I'm not exactly sure what, but I think there is work going on there.
Yeah. Awesome. So hopefully that's some good motivation for retrieval and why it's important. And I'm assuming most listeners here are familiar with that as well. So now, quick overview of semantic search. This is, I would say, by far the most common type of retrieval. Actually, maybe the real most popular one. I think like just using search engines. Like if you think about calling out to a search engine, that's a type of retrieval as well. But in terms of retrieval over your internal documents, semantic search has to be the most popular one. The basic overview is, and this happens during query time. You take the user query, you create some embedding for it, you then query it against your vector store. And so this vector store has already been pre-populated with a bunch of your documents, and these documents have been ingested, split into chunks, and embeddings been created for each chunk, and then they've been put in this vector store, like Zilla's or Milvis. And then, at runtime, you pass the search query in, you get back some documents, and you put it into the context of the language model, and it generates out an answer. And you can see here, like, the prompt doesn't have to be super complicated, like answer the question using the additional context or something like that. And there's a bunch of variants of this where you say, like, make sure you only use the context there, return any source citations that you used. So this box here is where a lot of like the prompt engineering in LangChain happens. This is high level. Before going on to kind of like, where this fails, which I think is an interesting discussion, maybe we can talk a bit about like the vector store, and Milvis and Zilla's in particular. And so I think a lot of people are wondering, like, how do I, like, one, I guess, like, what is a vector store? Why do I need a vector store? And then like, how do I choose one? And so from your perspective, as you guys are thinking about building like the best offering for a vector store, how do you guys think about that? What are the axes that you compare across? Yeah.
I think currently the biggest one that we're looking at is just ease of use. For a lot of users, kind of depending where they're at, they don't want to go run 6 Docker containers, set up the network in the Docker, connect to the Docker, do all that stuff. They just want something that can say, okay, pip install, import this, have it work. So that's been a big one. Then also kind of ease of use of the client. None of these vector databases have really settled on a language / style, like API style. For the SQL that people are trying to chase towards, there's like other ones. I think there's the GraphDB style, but there is no like singular language for doing this, no singular API. So trying to figure out what the simplest one is, how can we make things simpler without having the user have a bunch of arguments to set up the vector database and do all of these things. Because yeah, everyone can get pretty fast, but at some point you need to make it easy to use. We try to offer as many switches as possible. which is great for kind of big businesses where they have a team that can handle doing this stuff. But for a smaller user who's pretty new to this, do they really need all those switches? Does the extra 10 milliseconds really matter for someone who's just kind of messing around with it? It's kind of finding that balance, kind of creating options for everyone. That's been the main thing. But then again, on the big user side, we do want to be fast. We do want to be stable. We do want to kind of handle all the new features that are coming out. But yeah, it's a balance, performance versus ease of use. That's their kind of main looking point. But one thing that I was interested was, what's your opinion on kind of these new models coming out that are supporting token sizes of like, I don't know what the latest one was, but abnormally large token sizes where at some point you can probably fit your entire corpus of data into the prompt.
Yeah. I mean, I think the short answer is I don't really know. I don't think anyone knows. I think like it's so I've played around with the Anthropic one, the 100K one. I haven't played. I know there are some that are now like supposed to be bigger than that. I haven't played around with any of those. I played around with the Anthropic 100K one, and for a lot of cases where you just need to, like, I'll tell you what it works really good for. It works really good for, and I passed it our entire code base. And if I want to find like a single kind of like fact in there, it works really well for that. So it kind of just like finds that fact and extracts it. Where it didn't work amazingly well is where I asked it to combine like multiple things together. So to like give an example, we have the concept of agents in LangChain, and then we have different LLMs, right? And so a lot of the examples in LangChain that use agents use like OpenAI's LLM, just because that's, I mean, that's the most popular one, so it's in all the documentation. But so basically what I asked is like, can you create an agent using the Anthropic wrapper for me? And all that information is present in the code base, right? The Anthropic wrapper, and I have to like, how do I import the Anthropic wrapper? It knew how to do that. How do I start an agent? It knew how to do that. How do I start an agent with an Anthropic model? Kind of struggled with that. So like that type of, and I'm not sure if that was because like the context is really long, because I've seen it performing better at some bigger questions, but for those cases that I gave it, it wasn't working amazingly well. So I think I mean, this is a bit rambly. I don't think anyone really knows. I think it's really interesting to play around with. I've played around with it a bunch, and I wish I had time to play around with it more. I think there'll likely be, I think like there's also different use cases, right? Like some use cases you need really fast answers. And so the downside of 100K is it takes really long. But if you have that time to wait, and these models do get good enough where they can address some of those issues, and they just reason over everything, like, yeah, absolutely. So I think there's probably a place for a time and place for both. I don't know. What's your opinion? How do you guys think about that as a vet? So some of the hot takers might say like, oh, vector stores are no longer needed because of these long context length windows. How are you guys thinking about that?
Our kind of general thought is that a lot of the data will kind of be lost within the giant contexts because there's not going to be weight. I don't know. I've never really played around with it, and I haven't played too much with it. We've just kind of been reading papers and all that. We kind of lose some of the key information. Like if you have a question that really stands out for like let's say one sentence that occurs once, and or it's like pretty outside of the context of the story. I think Anthropic released some tests where they put the entire book and they found one line. That one line was kind of an easy one to find, I think. I remember someone was telling me. That's kind of like where I'm not 100% sure, but will it be able to remember things within that text? Will it be able to assign the correct weight to what it's trying to pull out from? And that's where we think it might not be able to do it. There's just too much information there where it won't be able to pull out the info. And then also speed. You're trying to answer a question about your entire repo. Yep. Every time you end up using it, you're gonna have to upload your entire repo, unless they do some caching method in the layers somewhere where you can kind of cache and get the response faster based on the first text that you put in. I don't really see it being too useful. Also pricing. Last I checked, it was pretty expensive.
Yeah.
So not too many worries at the moment, but we'll
Yeah.
see. I don't know, this area is just going so fast. And then
Yeah.
I have two QA questions that kind of pertain to this that we can probably answer right now.
Yeah.
So one of them is from Sunil, and I'll try to kind of summarize it. Given the model is trained on a set of data already, what is the model actually doing with the additional docs, i.e. external knowledge? Is it simply summarizing it, or is it somehow taking external knowledge into account in terms of generating answers?
Yeah, it's taking the external knowledge into account in terms of generating answers. So you can feed it a document that has a bunch of facts about I mean, you can feed it a document about like a code snippet from the LangChain repo, and then ask it like, what's happening on this line. How would you change this line to another line or something like that? And so basically, all language models are kind of like conditional generations of the next token. And so when you pass in additional context, it's now conditioning its generation on the data that you pass in. And so what that generation is, whether it's answering questions, whether it's doing summarization, it kind of depends on what you ask it to do. So if you ask it to answer a question, it's absolutely kind of like taking in that external context and using that to answer the question.
Awesome. And then one more from, sorry if I pronounced your name wrong, Evgeny. This kind of pertains to the docs and getting them into the vector store, which is, how important is it to properly generate chunks here? What's the best size for a chunk? What are the best techniques for chunk generation? I know there are some defaults within LangChain for how you guys are generating chunk sizes, but have you kind of looked into that and to see what these different chunks, how they work? What's
That's
kind of like the best route?
That's a great question. I was going to ask you what you're seeing from customers as well. I think like, I mean, I'm happy to give my take here. I don't know. Okay, so I guess even backing up a step, like what is chunking and why is it important? It's basically taking these long documents and putting them and creating smaller chunks of data with them. This is important because you only want to retrieve the most relevant chunks. So I think there's, I think there's, okay, and like, okay, so at one extreme, if you chunked everything into one word, that would be pretty useless because you lose a lot of the context. If you chunked everything into one document, you wouldn't have actually done any chunking. So I think that kind of like shows the trade-off. And like the smaller the chunks are, the less context you have. But the bigger they are, the one like the embeddings might be a little bit more. The embedding might not fully capture. Like there might be multiple concepts within that aren't fully captured. And then two, like you can't retrieve as many of them to put in the context window, holding the context window steady. So I think I've generally had better luck with smaller chunks, honestly. I think the defaults that we have in LangChain are a little bit large, and so I generally move it down to like maybe like a chunk size of like 500 tokens or something like that. A few things here. This is, purely a heuristic. I don't know if there's a right answer. There's a great tool by Lance Martin called Auto Evaluator, which lets you do kind of like this whole question answer pipeline, including like different chunk sizes, different chunk overlaps. So it's often useful to have overlaps in chunks to like basically carry through some of the context. And so there's a great tool by Lance Martin called Auto Evaluator that lets you experiment with different versions of these and then run kind of like an evaluation end to end to see for your use case what comes out to be the best. The other thing that I'll add, and I think this is something that LangChain has done pretty well, is it's really important how you create these chunks. So like by default, you could just split every token, right? But I think like the idea behind chunking is like as much as possible, you probably want to have like things that are semantically the same in the same chunk. And so a lot of the text splitters that we've added don't split on a token level. You can do that there's a default in there, but they split more on like characters that we think are like semantically meaningful. So for example, if you have like markdown, you have like the single hash mark or hashtag or pound symbol, and that's like a header one. And then you've got two of them, and that's header two. And then you've got three of them, and that's header three. And so if you start splitting on those recursively, you start getting chunks of text that are like in the same sections and stuff like that. And those are generally kind of like semantically meaningful chunks that should probably be together. And so we kind of like split according to that. Adding in another thing, this is something we're working on, and I hope to have a version of this out. Lance is actually working on it. He's doing a lot of amazing stuff around retrieval. You should have him on as a podcast guest, actually.
That'd be awesome.
Webinar guest. But like one of the things that he's looking at is when you split, you sometimes lose some of the contextual information about like where you are in the document. So in the example I just gave, if you just split on header 1s and then header 2s and then header 3s, when you split on a header 3, you lose a little bit of information in that you lose like, okay, what header 2 was this in and what header 1 was this in. And so there's this concept in LangChain of like metadata that's associated with each document. And so basically what we're working on is kind of like propagating through some of those section headers into the metadata to basically enrich the metadata as you go along. And then the idea there would be you can kind of like create, you can do chunking without losing some of the context of where it is in the document. That was my long rambly answer on a lot around chunking. I think it's really, really interesting. We've invested a bunch in a lot of text splitters in LangChain, and I think I don't know if I've seen that many other places that have. But I'm also curious for your take on this, Philip. Like, what do you see people doing as they're creating like things to create embeddings for to put in vector stores?
At the moment, we're kind of seeing the simple route. Definitely not doing this kind of analysis on kind of what type of documents being looked at and then grabbing based on the headers. Yeah. So for us, it's mainly been kind of just the simple chunk by X tokens. It tends to work pretty well for most users. I think for the results that they're looking for, I don't think like there is a lot to be improved upon. That's where we kind of point people to LangChain to kind of get a better pipeline. But it's usually just the basics. Or what they're doing is they're usually not storing these giants. So if they're going this PDF route or like their own data, they'll usually go through LangChain and then kind of give us what they use and they decide there. If it's someone directly using us without using LangChain or any of these libraries, their data usually is not these giant documents. They're kind of pulling already data out like QA data or something like that, where you can kind of chunk over, you can pretty much have your chunk be the entire document there.
Yeah.
It really depends, but normally we don't really see, they kind of just say like, okay, we have these embeddings. How can we make our search better and faster?
That makes sense.
Yeah. I think there are a few more questions here, but I think for one of them, we'll be going over it later in terms of conversational memory and prompts. So yeah, I think we could kind of continue.
Cool. All right. I have a few more questions that I want to ask you around the ingestion pipeline as well, but we'll move on to some future slides for now. So, okay. What are some edge cases of semantic search? There are a bunch that we've kind of noticed. I would say semantic search is and I really liked what you said about the ease of use of getting vector stores to be easy to use, because I do think that semantic search goes a long way. It gets you, I'm not going to put an exact percentage on it, but probably somewhere between like 80 and like 90, 95% of the way there, depending on your use case. And so I think making that really easy to do is really enabling for a lot of developers. But I think there are some edge cases that start to arise as you progress. And a lot of these are kind of just heuristics on top of semantic search or around semantic search. And so, yeah, the overview of them here. There's probably a bunch I'm missing, so I'm curious for your take on them as well, Philip. But I'll just run through a few relatively quickly. So first, repeated information. So when you have like documents that are exactly the same copies of one another, or just have like really similar content. And so like, why does this matter? One, like when you do retrieval, you're getting a lot of copies of the same thing, and that's not exactly ideal for providing the language model with the best possible set of information that it needs. And then like very correlated to this is just takes up more context. So in order to get that diversity, you'd have to like really increase the number of documents that you have, and then that just starts to take up context. So some of the things that we've seen and implemented in LangChain here. One is the idea, one's the idea of basically filtering out similar documents. So like you do a big retrieval step. And so normally, like by default in LangChain, you pass in, you do a retrieval and you fetch back like 4 or 5 documents, and then you pass those into the prompt. And we generally choose 4 or 5 because of like the context window lengths, and that's like a reasonable default. But one thing you could do is basically fetch like 20 or 30 documents, and then you just filter out ones that are similar, either through embeddings or by passing them to a language model. And embeddings are probably the faster use case here. And that's we've implemented in this idea of like contextual compression, which is the idea of basically you retrieve documents and then you do something to kind of like compress the information in them relative to the query that comes in. And so that's one thing here. Another thing you can do that we've implemented on most vector stores, I believe, is have a different type of search. So rather than doing semantic search where you basically select the documents that are most similar, there's another type of search called like max marginal relevance, which basically takes a vector, and then when it's selecting vectors to retrieve, it optimizes not only for similarity, but also diversity from other vectors that it's already retrieved. And so the idea is basically, yeah, if you have 2 vectors that are exactly the same, as you start retrieving them, you're not going to add them if they don't add much. And there's different parameters you can tune there. Another thing that I'll add that I forgot to put here, but it's just as simple as you can kind of like deduplicate documents before they come in. You can do some deduplication process. That's maybe like yeah, I mean, I guess like one downside of that would be if you have documents in like location A and location B, and you deduplicate them, like what do you put as the location? Do you put location A? Do you put location B? Will that actually matter for your application? Like if you're citing sources or something like that. So it's a little bit more risky there. What are your thoughts on this, Philip? Have you seen this pop up? Have you seen any other techniques? Which of these 3 do you think people do most?
I would say at the moment, it's a little tough area to do because for document deduplication, unless you're doing exact pattern matching, if you're going just by the embedding, yeah, you could do like a search to see, okay, what's the closest result? Like what are the 10 closest result? Kind of set a scale for what's the closest, like what's considered a duplication, and then kind of remove. The only issue there is you don't really know what level you set your similarity in the score to mean a duplicate, because again, one element of the vector could be completely different, meaning that everything could be different. These are such large embeddings that deduplication is hard. One thing I think I had a question. I'll ask it after in terms of the compression. But another thing I think we messed around was whether compression was taking like, yeah, as you said, your top 10 results and then summarizing across all of them and then using that in your prompt. So kind of, even if they don't hit as accurately, you can still summarize across all 4 to make it a single document and then use that in your next question, which I'm guessing is what you guys were also doing in the contextual compression.
Yeah, there's a variant of that.
But yeah, in terms of getting rid of repeated information, it's difficult unless you know a document's going to be pretty similar. Then you can just kind of do an upsert based on the primary key of the document. But if you really want to get rid of like contextually repeated information, I don't think we have a trick for that yet.
Yeah. All right. Jumping into the next thing that I've seen often pop up, conflicting information. So you have the same answer for multiple sources. So like a way of thinking about this is like in your Notion database. You might, let's say, what is the vacation policy for your company? You might have an answer. You might have answers for that in different places. Like maybe the answer is kind of like changed over time. And so there's like the master kind of like HR document and the answers there, but then there's some like random meeting notes from like a year ago where they discussed the vacation policy, and so then the answer is there. And so when you do a retrieval, you pick up information from one place and pick up from any information from another place, and you pull them both into context, and you're now asking the language model, like, hey, like, you know, generate the answer to the question, like, what is the vacation policy based on the following information? And the following information has two conflicting sets of information. So what do you do there? Some things that we've seen is basically when you're retrieving sources, you can have some notion of importance built in. So in the example above, you'd probably weight like the HR document higher than the random meeting notes. And if those are the only two documents retrieved, this doesn't do much. But when there's a lot of documents, you can add some importance weighting and kind of filter those up. The other thing that is maybe a bit more robust is you can pass, well, it's more robust in some ways, is you can pass like the source information, the metadata, to the generation step. So when you pass it to the generation step, you don't just say like, you know, here's a chunk of text that was found that seems relevant. You also say this was found like in the master HR document. And then for the other one, you say like this was found like in meeting notes on like, you know, 3/14/2022 or something like that. And language models are pretty good at like ambiguous reasonings. They should, if you say like, you know, if they're, and this gets back to some of the prompt engineering and prompt construction, if you say like in the case of like conflicting information, like choose the one with that of the source that seems more credible, that should help there. That's what I've got for conflicting information. Have you seen this pop up at all, Philip? Any other, and these are all like edge cases. So to be clear, like I don't think these are extremely common for the audience listening. But you know, as you start to encounter these, just trying to provide some context on what might be going on behind the scenes.
Yeah, I think for us, a key one has been if you can get kind of dates and just do metadata filtering based on dates, where you kind of assume the most recent knowledge is the best knowledge. Sure, there are cases like that where you said it's HR saying something or it's some random thing saying it. In our sphere, outside of metadata filtering, we don't have really the ability. It comes again more closer to your domain of the actual kind of prompting around.
Yeah.
But yeah, kind of if you can use the large language model, as you said, it can usually kind of figure out, okay, if it can then analyze the question, see a answer from HR is probably better. But just from like the raw side of it, metadata filtering, kind of trying to see if you can kind of kick some results out and have a higher chance of getting the result you want. If you know, like random forum, if this comes from a random forum, most likely there you don't want to use that as your result, filter out all that data. But yeah, it really depends on how you can structure your data and what information you have ahead of time. Again, with importance weighting, that kind of is difficult to also do because you also kind of have to have a say in how important it is. Without, if you don't want to use the large language model, you kind of have to have that metadata at hand. Where then, yeah, importance weighting you can kind of just filter out as well. But kind of automatic things, you'll pretty much have to fall back to the large language model to have it decide.
Yeah. Next one, related to the previous one is, and related to some of the stuff that you talked about, is just temporality. So information can update over time. So yeah, you know, the vacation policy could change from one date to another, and both documents could still be in the database. So I think like some solutions that I've seen here, and I think like two of them are very similar to before. So the recency weighting and retrieval, or recency filtering, as you said, I think that's a good way to filter them out completely. You can also include the timestamp in the generation step, so you can tell the language model to trust more up-to-date information more. The other one is an interesting one, and this doesn't apply in all situations, but the idea is basically to use reflection to update your concept of something over time. So in the example of the vacation policy, in addition to, and this is, okay, so I mostly see this used in like conversational settings where you have a chatbot, and I'm chatting with a chatbot and I'm talking about my friend Philip and what he's up to and what he's doing and things like that. And so rather than one way of adding memory to that chatbot is just to retrieve kind of relevant pieces of what I said about Philip when I talk about Philip the next time. But another way of adding memory is to create this idea of similar to like a knowledge graph where it has a concept of Philip and who Philip is and what he does and what he likes and all of that stuff. And so then as information comes over time, that entity is like updated in the knowledge graph. And I think there are a lot of downsides to this. The reflection step uses a language model, so it costs more money and it's kind of slow. And so I think it's still very experimental, but the paper we'll talk about at the end, the Generative Agents paper, uses this technique. And so I'd say that one's a bit more researchy at the moment, but I think very, very cool. And then the other two are a bit more practical. I don't know if you have much more to add here. This is pretty similar to the one we've talked about before.
Yeah, mainly just kind of timestamp based and date based. I feel like there are, like, once you start bringing in, if you have the funds to start pulling in LLMs, you could also then kind of use LLMs on your metadata that you stored with a vector and then decide, oh, do we want to combine this? And then kind of keep updating and upserting. But yeah, in terms of our side of things, we kind of, the issue with our side of things is that we try to do as much as we can just based off the raw data like that we get. Trying to avoid as many LLM calls as possible. So that gets expensive and
yeah. This is a cool one that we've added recently. Basically, sometimes questions can be more about metadata than content. So I think an example of this is like if you have a user question that's like, what's a movie about aliens in the year 1980? The semantic content, and so to back up even another step, like embeddings are really good at capturing semantic meaning of things. They create this dense representation of text. And so the semantic thing, the concept that the user's looking for are movies related to aliens. But there's another thing, which is this like basically metadata filter, as we call it, which is like you want the year to be set to like 1980. And this is like a very like exact match type of thing. Depending, it totally depends on the schema, obviously, but like this could very well be a field in the schema that you want to query, and you basically want to filter results based on that. And so we added basically kind of like a self-query mechanism that before it does the semantic search retrieval, it actually splits this out into two things. It splits it out into a metadata filter, and then it splits it out into the query itself. So in this case, you'd get a metadata filter, which is like exact match year equals 1980, and then you'd get a query, which would be like aliens or something in this case. And so then when you and then there's a question of like, how do you apply the metadata filter? A lot of vector stores have ways to pass in metadata filters, and so you can kind of do it directly in the query. If that doesn't work, you can probably also filter things out after it comes out of the retrieval, but pretty much all of them have ways to pass metadata filters in. And so basically then you pass in this metadata filter along with the generated aliens query, and it kind of like combines the best of both worlds. You get the semantic search with this like exact match filter that you can apply.
Have you tried doing that on the other side as well with self-inserting? So you can kind of go take a batch of your insertions and then kind of generate kind of a schema for what you want to insert. So you know the filters. You can maybe extract what you want to filter on the columns, and then later on you do the same for the querying, and it can decide based on what it sees in the schema. Probably be expensive, but that would be interesting where it can kind of decide what metadata it wants to pull out of the data.
Yeah, that is, we haven't done this. That we've thought about it framing exactly as you just said, like what metadata should we attach from a document. Yeah, that let me make a note of that. I'm gonna Slack Lance about that right now. Extract metadata during ingestion. All right, we'll add something there. That's a really good idea. Yeah, because I think like, I mean, this goes back to the ingestion part, but like even if you're not doing this self query, it's still really, really useful to have this enriched metadata type thing, right? And so yeah, Stan, so I think who had brought this up? I think we were chatting with someone from Zapier, and they had brought up a similar thing as well. So now that's two people, so that means we definitely have to do it. So
only issue I can see is then you're making an LLM call for the metadata, also an embedding call. So then it's getting expensive, unfortunately.
Oh yeah,
But
yeah. But I think like you do probably have to trust that like LLM costs are going to go down and latencies are going to go down over time, given the whole speed of everything. And also, like, another thing I'll just say is, like, you don't need to do this for every use case, right? Like, you can
that
do
is
this
true. Yeah.
kind of as desired. It's another, that's the thing with like the space right now, is I think there's no one right way of doing everything, right? Like,
Oh yeah.
I think and a lot of what we view LangChain as is just these components, kind of like tools in your tool belt that you can use for like different use cases. So if you really want to care about this, and it's really important that you do have like this like identifiable metadata, it's an option, but it doesn't mean that it's the right thing. Again, semantic search gets you 80% of the way there for like a bit, or it gets you there for 80% of the use cases. And so, yeah.
Awesome.
Multi-hop questions. So this is another one where you could maybe be asking multiple questions in one thing. And so I think like there are a lot of examples of questions like this. I think some of them, I first started thinking about this when the React paper came out, which synergizing reasoning in action, an early version of an agent. You've basically got these questions, like, what's the population of the capital of Kansas? And so then you've got a question like, what is the capital of Kansas? And then what is the population of that city? And so the issue with semantic search here is that if you just look up the original question, it might pull in one part or the other part, or it might pull in like the population of capitals, but not of Kansas, or it might pull in the capital of Kansas, but not population information. And so it's basically this kind of like multi-hop thing you need to do. And so agents are just a way of saying, break the question down into multiple steps. And so use the language model as a reasoning engine. Think about what piece of information you need to look up first. Okay, what's the capital of Kansas? And then think about what's piece of information you need to look up second. Okay, what's the population of that city? And then do those in separate queries. And by the way, some of these queries might not be to the same database, right? So like one could be to a vector store, another could be to a SQL table. And so and this starts to get more and more into like just the idea of like a generalizable agent that you can use for retrieval. And again, as discussed, racks up a lot of LLM calls. It can go off the rails a little bit more easily. So I think it's, again, just another tool that you can have in your tool belt here.
Awesome. Now, speaking of racking up LLM calls, I know we've been working in like the caching of the LLM calls. I think you include that also in LangChain now, but GPT cache.
Yeah, GPT cache.
So
yeah, great project. Yeah.
hopefully that kind of helps out with these use cases where, who knows, you might be sending the same first question multiple times. If you're asking multiple questions about the city of Kansas, split up, maybe it will hit the cache a few times and you might save some money, but who knows?
Absolutely.
Awesome.
Cool. Okay. The last thing I want to talk about really fast, and then we can probably go to some question answering for the remaining bit, is a paper about generative agents. And so this came out of Stanford about 2 months ago. The basic idea is they set up a simulation of these different agents that were interacting with each other, kind of like in The Sims. So they had like 25 different agents. They all had kind of like their own, they all could take their own actions, and they all had their own like memory, basically. And so how they did the memory, I think, is really interesting, because I think memory is really like retrieval of relevant information at the right time in some senses. And so I think how they did it is pretty interesting and pretty instructive to look at. And they use the concept of, so basically what they did is they had all these observations, and then they would basically fetch relevant observations and then put them into context as the agents were deciding what to do next. And so what exactly was going on in this retriever? There were a few different components. There was the relevancy component, and this is where like the semantic search bit comes into play. So they'd calculate kind of like the relevancy of the current situation to previous situations and bring in information about previous situations. Importance also came into play. So they would retrieve like more important information. And to your point around like, how do you do this in an automated way? Yeah, they used a language model to assign importance to memories. And so there was that extra cost inferred there. And then recency was also another bit. So they gave more weight to more recent things, not out of the sake of like trying to deduplicate conflicting information or anything like that, but just more recent memories are probably more relevant. So pulling that in. And then on top of that, the other thing that they added in, and this is similar to some of the to some of the stuff we talked about earlier, was a reflection step. So they kind of had a reflection step that at each time period they would do reflections on the past like n observations and then add that as a memory. And so then they'd start pulling this, and they treated that just as every observation, just as every other observation. So in terms of the retriever, it didn't change anything about the retriever at all. The retriever was still a combination of like relevancy, important, and recency. But the thing is now, the things they were retrieving weren't just like individual observations. Some of them were also reflections on those individual observations. And so a way of kind of like pulling in higher order kind of like reasoning about those. I think, again, this was a research paper. So this is probably not, this isn't production ready. But I think it's a really interesting look at how like more complex types of retrieval can power like really interesting and dynamic simulations and situations.
Someone had a question in the chat. If you have a link to that paper or what the paper is called.
Yes, I think it's called Generative Agents, but let me find a link to that and I can drop it in there. Generative Agents, Interactive Simulacra of Human Behavior. I'll drop it in the chat. Oh, someone beat me to it.
Yeah. Awesome. Not sure. We have a few Q&A questions if we want to go over them. Not sure if you had more slides, but
that's all I had, unless there's other things that you think we should talk about.
I think that pretty much got the gist of memory in terms of LLMs. But yeah, let's go through these. So we'll start with a big one from Surya. There's a belief that the future of LLMs is about separating the reasoning ability of the model from the knowledge the model holds. This leads to models that are experts at reasoning about tasks, but maybe don't have all the knowledge about everything, and see this as how people will use LLMs in the future. What are your thoughts on this? Might be nice if you can discuss a few examples of this scenario.
Yeah, I think I think there's definitely a lot of validity to it. I think that's a lot of the underpinnings of this idea of like retrieval augmented generation. Like you're pulling in the relevant context and then you're asking the language model to reason over the relevant context and the question and provide an answer rather than just use information that's in its weights. There are so I think there are, there absolutely are a lot of very valid reasons to think this way. Obviously there's a lot of applications where you don't have to do this as well. Like language models are like good at having conversation. And maybe like here's one distinction I'd draw is like, are you interacting with the language model for the sake of its reasoning ability? Or are you interacting with the language model for like entertainment or anything like that, right? So like, like if you look at character AI, like a lot of their characters it's for entertainment purposes, right? And so I don't think they do a lot of kind of like this retrieval augmented generation. When you start getting into and then there are, people use ChatGPT for a lot of information, right? And it's pretty good at a lot of it, and it gets it a lot of factually correct. And so there are also works being done to like improve the underlying kind of like factuality of the LLM, so they don't just like make stuff up. I think even if you have a language model that doesn't make stuff up and doesn't hallucinate, and when it knows and when it doesn't know an answer to a question, just like says it doesn't know, and as opposed to make stuff up, which is the current situation, you still probably want or like this idea of like combining the language model with other data is still extremely relevant, because there's always going to be data that the model's not trained on. And so then the option is to train the model on that data. Fine tuning right now is much more expensive than a lot of this RAG, the retrieval augmented generation style stuff. So that's a long way of saying, I think, I guess the question is about the future of LLMs, and I'm really hesitant to make predictions about the future because I don't really know anything. But I'm guessing there's absolutely a place for this in some form in the future.
Let me pull out the next one. So someone had a question about conversational memory. How are we storing the previous conversations? And they're more structured and much better than free-form conversation. So I guess, yeah, conversational memory, like what the route is for storing this and retrieving from it.
Yes. I mean, the basic thing that everyone's doing with conversational memory right now is you just keep a buffer of the previous messages and conversation. So it's entirely recency weighted. I'm pretty sure that's what ChatGPT does. I'm pretty sure that's what Character does. Could be wrong. But I think they're just keeping around this buffer of most recent messages. And as the context windows get longer, you can keep that buffer around for like a longer period of time, et cetera, et cetera. I think there's, when you talk about extending that, yeah, like all the same stuff applies. You could do, I mean, as you pointed out, they're less structured than some of the structured information. This is actually a really good question. Yeah, I haven't thought too much about the differences in terms of how you'd want to do retrieval. I'm guessing you'd probably want to treat the conversation as a whole document as opposed to each message as a document. You'd probably want to have a decent amount of overlap in the conversation, maybe more so than a structured document. But that's a really good question. I haven't thought about it in too much detail.
Another one about chunks is for long documents, is there a way to select the best end chunks to use to summarize, leveraging the vector stores? What's the best way to think about this? So is there a way to kind of filter out what you don't need?
Yeah, I mean, I think to some extent, it depends on the questions that you want to be asking of it. If you're asking it to like summarize the document, you probably want to have the whole document you probably want to use the whole document. If you're trying to extract like questions about it, then I think using a vector store provides a very natural way to do that. You kind of like split it up into chunks. You only retrieve the chunks that matter. You don't set like a high level of chunks. So yeah, I think it depends a bit in the questions that you ask of it. I also think, and then like, how do you determine the chunks? This gets back to the original point where right now it's like all heuristic space. There's kind of no things with all this stuff. Like let me drop a link to like auto evaluator that Lance Martin made. That's really good, where you can pretty easily kind of like experiment with different versions of all of this. Yeah, like I think I just put that in the chat. So I think that's I think that's a pretty good way to, yeah, basically it's gonna there's no one universal answer. You should try out a bunch of different things and see what works for you, and auto evaluator is a good way to do that.
And then we have another one is any impressions on how effective compression strategies are in practice? So I assume this is for document compression.
Yeah, I mean, I think it's still pretty early, so it's I don't know is the honest answer. I think there are edge cases where it definitely works. I think the big question, like, I don't think there's any debate that it like works. I think the question is about like ROI and like, you know, is it effective in terms of like the cost that it incurs as well? And I think the jury's still probably out on that, and it depends a little bit on your application, probably.
And how does the weighting of information work? How would you implement it? Metadata level in the prompt? Yeah.
Yeah, okay, taking some concrete examples, the generative agents paper, what it did is it did a retrieval step based on semantic similarity, and then it re-ranked things by incorporating importance into that. With like there's some, there's some like lambda in front of the importance score and some lambda in front of the similarity score, and then also some lambda in terms of the recency score, I believe. And so I guess the general, so that would be one way of doing it. Basically, like combine the importance score with the similarity score to re-rank things, and then take the combined like top 3 or 4 documents after that re-ranking. You could also do it in the prompt. This is a bit more, the generative agents is a very concrete application of this. Putting it in the prompt, you just need to then do some prompt engineering to tell the language model to pay more attention to it. Haven't seen this one done as much in practice. It's mostly been kind of like re-ranking and reordering after fetching documents.
Let's see. Regarding the components described in the generative agents paper, how well do such concepts map into general higher order abstractions that can be composed into useful applications? Is cost inherently problematic for the foreseeable future?
I mean, I think so around cost, I think honestly the biggest blocker for most things is like still getting like product market fit, to be honest. I think like getting stuff that works and is useful is a bigger blocker than cost. After that, cost, yeah, it probably becomes problematic. But I don't think, like, even if you put cost aside, I haven't seen a lot of projects that are really diving deep into this type of memory or this type of retrieval and really optimizing stuff there. That was the second part of the question. What was the first part of the question?
How does this concepts map into general higher order abstractions that can be composed into useful applications? I think you did both. English. And then we have one as, what is your perspective on the evolving trends towards intimate and private engagements with AI? With an increasing number of conversations being entrusted to AI systems, conversations which typically would have been exclusively human, how can we design and implement trust-based mechanisms to ensure these interactions remain secure and privacy-centric?
Yeah, that's a good question. I'll preface this by saying I don't really know, so you should take everything that I say after this with a grain of salt. But I think like there's definitely, like, off the top of head, there's like 2 really big components that I can think of. So one is like making, for these more like private and intimate conversations, like making sure the language model really does not suggest things that are harmful in any way, right? Like if you're having these types of conversations, like it should not be saying anything that is harmful or could lead to violence or anything like that. Because you're really, it's much different than if you're interacting with like question answering over a random document, right? Like the stakes are a lot higher there. And then the other thing is around, so that's maybe one around like safety, and I think this is much more safety of like the underlying models. Then there's like the privacy, and probably like the privacy of this whole system. And so yeah, making sure that your data is as secure as possible. Does this mean like a locally deployed LLM? It could also mean just better privacy policies from some of the cloud ones. It probably depends on your risk tolerance. I don't have a super strong thing here. I think obviously local LLMs would be ideal, but I don't 100% know if that's a blocker, if there's really good security measures put in place. Like we entrust a lot of our personal information to the cloud as well. Yeah, it's a good question though.
I think we have time for one more. Okay. When using LLMs for summarization and reasoning based on semantic search, are there any open source models you suggest for that particular purpose?
I've had the only one that I've had any luck with is Mosaic's MPT 7B model. I've tried out a few others. I haven't experimented too much. I think Vicuna is not terrible. So I take it back. The MPT 7B isn't the only one that I've had success with. I think like Vicuna and then that one are two that I've had a little bit of success with, but still super early on in the open source days. So there'll probably be a lot more.
I think we're at time. There's probably 4 more questions we can probably get answers to later, maybe. Just so we don't go too far over. Not sure if Emily wants to take over.
Yeah, it's up to you. Harrison, if you've got a couple extra minutes, we're happy to take a few more questions. But if you've got to jump, then we will probably do a follow-up blog with answers to those questions.
I do got to jump. I
right.
appreciate you having me on here, but I got a conflict that I got to jump off to.
Of course, we understand. Philip, Harrison, thank you so much. This was a really great session. Thank you for all of the wonderful questions from our audience. We hope to see you on a future Zillow's webinar, and keep an eye out for that blog post. We will do our best to get the rest of those questions answered, and you'll find that on the Zillow's blog. Thanks, everyone.
Thanks.
Thanks. Bye.